Where others found the dumpster the most appropriate place for this amplifier, I saw an opportunity. My goal with this project was reliability and sonic purity. I wanted the electrical performance to be exactly what the Technics engineers intended in 1975. Have I bit off more than I can chew? Well, that's ahead. If you saw this amplifier sitting at a flea market or in the back of a recycling center, you'd probably keep walking. It's scarred, it's scratched. Somebody even carved their name into the faceplate. It looks like it's been dragged behind a tour bus for 3 decades. But this is the Technics SE-9600P, and despite how it looks on the outside, inside it is now brand new. Today, on Vintage Audio Addict, I'm going to show you why I spent hours rebuilding this beat-up unit, why I refused to paint over the scars, and why the best sounding gear isn't always the prettiest. I obtained this from a local high-end dealer who basically said he was waiting for trash day to get rid of it. That wasn't going to happen on my watch, so I brought her home. Like every unit I don't know anything about, I took a look at this one, but this one being in the shape it was, I was going to take a little bit better look at it because I just figured there's probably going to be something really wrong with it. So I took my time and gave it a good look. Obviously, you could tell from the faceplate it was in rough shape, and the back panel, the same thing. It's got some rust and it's just in rough shape. That's the only thing you can say. Looking at the top of it, one of the covers are missing. It had a couple of the covers, but one of them's just missing and didn't get it. The guy at the shop said he didn't get it when he got the unit. So I took the bottom cover off, and that area actually looked quite good. It looked like a normal amplifier. There was no corrosion. Looks like nobody's ever been in it, so that was good. The only thing I did find in the bottom was a screw. Now, where that came from, I don't know. Looks like a sheet metal screw, a wood screw. I don't know where it came from. I never did find out. This was one of those times where I actually found something by looking at the unit, and I'm glad I didn't power it up with that loose screw in the bottom. Before I go on, I've got a quick question for everybody. Every time I talk about a Technics product, somebody down in the comments says it's not Technics, it's Technics. Is it pronounced Technics or Techniques? I've always called it Techniques. And I found a Japanese advertisement that to me sounds like the guy is saying Techniques a lot closer than Technics.
Technics カセットテープ原音への旅立ち
Interesting way to keep the cassette toppling going. So just put down in the comments the way you guys pronounce it. Do you pronounce it Techniques or do you pronounce it Technics? Okay, it's time to get back to the Technics 9600P. After giving it a good visual look and getting that screw out of the bottom, I thought I'd take it outside and maybe just clean it up a little bit before I tried to power it up even. Best way to clean a unit like this up is outdoors, so that's what I did. I just brought it outside onto the deck, and I went ahead and used a paintbrush just to get the worst of the crud out of it. I wasn't out here trying to make it look brand new. I was just trying to make it so it didn't leave a whole bunch of stuff inside. With the worst of the debris out of the unit and it looking a little bit better, or as good as it can, it's time to get it back up on the test bench and get ready to power it up for the first time. I had no problem finding a service manual for the 9600, and that's 99% of all vintage audio equipment. You're usually able to find the service manuals for them. Using a dim bulb tester, I powered the 9600 up for the first time, and it looked like it powered up just the way I would expect it to. But neither the power lamp nor the power meters were illuminated at all, so that gave me some concern that maybe the unit didn't power up. While I'm staring at the front panel of the 9600, I want to go over a few of the controls because a couple of them are unique to any amplifier that I have. At the top right, you've got power meters, which is not unusual on a power amplifier. Just under the meters are meter sensitivity switches, again, a common thing on a power amp. Down at the bottom left, you've got a power switch. Then you've got the speaker select switches. It supports 2 sets of speakers. You've got a headphone output jack. Then if we skip over the next two for a minute and go over to the bottom right, we've got our left and right channel output controls. And that's not unusual on a power amp either. But the ones we're going to talk about are those two that I skipped over. The ones marked output impedance and input. Let's take a look at the control marked output impedance first and see what that's all about. This switch controls the 4-stage output impedance selection. 0.08 ohms is the normal position you would leave it in. The other three are 0.8 ohms, 2.7 ohms, and 8 ohms. Depending where you had the switch set, it affects the amplifier's damping factor. In the normal 0.08 ohm position, the damping factor would be 100. In the 0.8 ohm position, it would be 10. In the 2.7 ohm, 3. And in the 8 ohm, it would be 1. Most modern amplifiers strive for the lowest possible output impedance to achieve a high damping factor. Damping factor is the ratio of the speaker's impedance to the amplifier's output impedance. A high damping factor in an amplifier will allow it to control the woofer's motion in your speakers much better, and it'll be much tighter, and you won't get any unwanted moving after a bass note stops. I really don't know the reason why they have this, other than that it'll mimic the output characteristics of many tube amplifiers if you run the damping factor lower. So next up, you've got a switch marked input. You've got two choices. It's either on or off. What's that all about? On most power amplifiers, there is no input switch. The amp is always listening to the preamp. On this 9600, it includes a dedicated input muting switch. When it's on, it works like any other power amplifier. It passes the signal from your preamp through those RCA jacks to the amplification stages. Now, when it's off, the input signal is grounded, effectively silencing the amplifier without powering it down. Now, why would you do this? The idea is that you can swap out your RCA cables between your preamp and your power amp with the power on. Does this work? I'm sure it does, but I'm not going to try it. I'm not going to pull my RCA cables out of my powered up power amp. I'm just not going to do it. I'm just going to turn the power off. The power button's right here on the left side of the unit. It's no big deal. Another unique feature on the 9600 involves the heat sinks. And first of all, these heat sinks are what you would expect from a middle 1970s Japanese power amplifier. Big, heavy, and substantial. But that's not what's special about them. Let me show you what I mean. The die-cast aluminum fins have a heat warning built into them, and here I'm showing a view of the amplifier from the top. I've highlighted the heat-sensitive paint on both the left and the right power amplifier heat sinks. It's that little yellow-greenish dot that you see in the image. The color of this heat-sensitive paint doesn't change until the temperature of the heatsink rises to about 120 degrees Fahrenheit or about 50 degrees Celsius. What I'm going to show here is a time lapse of how, at ambient temperature, this heat-sensitive paint is this yellowish green, and as the heat sinks arrive at 120 degrees Fahrenheit, it turns to an orange-red color. Now keep in mind, the amplifier can run fine at this temperature. It's no problem. It's just a safety feature for the user, so they realize that these heat sinks do get quite warm. Let me get back to why this 9600 apparently didn't power up when I turned it on. I saw no illumination from any of the lights. When I powered it up on the dim bulb tester, the bulb flared up briefly and then it went dim. And that's the primary indication that the amplifier is powered up without any sort of catastrophic short circuit. However, I had no lights, and that's not necessarily any indication other than the piece of equipment is old, and a lot of times these lights are burned out. But I've got 3 of them, and I'm thinking to myself, are all 3 burned out? I mean, that's a possibility. But you guys who have vintage equipment, what else are you looking for in an amplifier? At least an amplifier from this era. You're listening for that speaker relay click. And if you hear that, you probably have an amplifier that is almost certainly functional. The protection circuit had scanned for DC voltages, found none, and it connected the amplifier outputs to your speakers. And I really shouldn't say found none, because there's always going to be a little bit of DC voltage out there, and many times these protection circuits, they don't kick in until you get a half a volt, 3/4 of a volt or more. That's 500 millivolts, 750 millivolts before the protection circuit will even kick in on most pieces of vintage equipment. I was pretty confident that the amplifier had powered up, but I wanted to take a look and just see what my DC offset was sitting at, so I went ahead and just hooked up my meter probes right to the speaker outputs on the unit, and I took a look at the voltages, and they were great. I couldn't believe it. I mean, it looked like it had just left the factory in Japan in 1975. I was amazed to see only about 2 millivolts of DC on the left channel and about 4 millivolts of DC on the right channel. You guys need to keep in mind too on your pieces of equipment that most of them from this era had speaker protection circuitry, but some did not. And the earlier amplifiers and receivers are more likely not to have any speaker protection. So an amplifier receiver with no speaker protection may power up, seem to be fine. You hook your speakers up and you toast them. So always check that DC offset before you hook up any pair of speakers to any piece of equipment that you've just acquired new. Next, I hooked up a pair of speakers and a CD player to the 9600 and just gave it a quick listen, and both channels sounded good. Now I'm going to try to get the power indicator lit back up, and I'm going to try to get those power meters lit back up. So I took a look at the schematic. The power meters use 6.3 volt lamps, and the power indicator lamp is 7.5 volts. So I found the 6.3 volt power meter lamps available on eBay. So I went ahead and ordered those. And the power lamp, I went ahead and decided to change that out for an LED. The lamp replacement in the power meters was not plug and play. I had to remove the meter assemblies from the chassis, so I removed both of those out. And then you have to take the case apart. It doesn't just pop open for you, or there's no screws or anything like that. You just got to be careful. Pry open the case. And then when you get to where the lamp is, then you've got to solder that lamp in. It's not like in a socket, or doesn't make it too easy for you. It's really not that difficult. Just these meters are extremely delicate, and you just got to take your time. And if something's not coming loose, don't try to force it open or you're going to crack the plastic. The old saying, patience is a virtue, comes to mind when dealing with these meters. With the power meter lamps changed out and the power lamp changed for an LED, I was ready to give it a try. As soon as I turned it on, the power LED came on, looked good, and what do you know? Look at those power meters. They haven't been lit for who knows how long. Years, decades, we'll never know. But now it looks like it's 1975 to this amp again. With the power meters and the power indicators back lit like they should be, now it's time to move on to the next phase. For you guys who've followed my videos over the years, you know I'm a big proponent of getting those old 50-year-old electrolytic capacitors out of my equipment. And that's what I'm going to do. I'm not going to preach, should you do it to yours? There's plenty of information out there, pro and con. So I'm going to get started restoring this amplifier. I'm going to start with the power supply in this amplifier, and it's located at the bottom of the chassis. That may not be the best place for a power supply. They generate quite a bit of heat in these units, and the heat's really trapped down under there, has nowhere to go, so it kind of stays in there. And any of you guys that have any equipment, whether it's an amplifier, receiver, or any other piece of vintage electronics, the power supplies are under a lot of stress in these units for the most part, and they generate a lot of heat. A lot of heat, a lot of stress means that a lot of the components are probably stressed also, and it's always a great place to start if you're rebuilding any piece of old equipment. I've got the screws out that hold the power supply assembly in the unit, and just give it a little tug here, and there it comes. It pulled right out with no issues at all. Interesting with this, which is a little bit unusual, I didn't even have to cut a tie wrap or anything. I just took out the screws and moved it a little bit, moved it around, and it just laid right on down on the table for me. And it's going to make it easy to get in there and change out those old electrolytic capacitors. Usually you got to fight with it a little bit more, but this one, it's about as easy as it gets. I got the parts together and I started to replace the electrolytic capacitors. I've mentioned it before, but my desoldering tool is invaluable to me. It makes the job so much easier. I personally wouldn't attempt a restoration if I didn't have this desoldering tool. It just makes the job so much easier, so much safer for the equipment. If you ever attempt to take this on, I recommend you do them one at a time, one component at a time. Take out the old capacitor, make sure you take a look at it, the value of it, make sure that your replacement is the correct value, the correct voltage before you put it in. There's just a lot less chance of you making an error instead of taking out 4 or 5 at a time, and there's just a lot more things that can go wrong. And believe me, you don't want to get this back together and then have it not work. Or worse, that whatever you did incorrectly caused damage to the unit. And with electrolytic capacitors, you got to make sure you get the polarity right. So just take your time, and if you got a really good chance when you put this back together that it's going to work for you. After changing the electrolytic capacitors out, the only thing left to do now is to go ahead and mount the power supply back into the chassis and to give it a try. You should always check your work if you can as you go. work on one assembly, put it back together, make sure it'll power up, make sure you didn't break something, because it's much more difficult if you do the whole project and then you get everything back together after you've worked on the entire unit, you power it up, something doesn't work, and now you'll spend forever trying to find it. The 9600 powered up fine. I gave it a quick test and all was good, so it was time to move on. Up next is the left and right driver circuit boards. I put the bottom cover back on so I could set it on its feet, and now you're looking at a top-down view, and I'm going to work on the driver assemblies. This one here that I'm taking the screw out of is the left driver assembly, and you can see over on the left of the screen as you look at it, there's the right one. After removing 2 screws out of the cover, you can see the left driver assemblies exposed right there. And the right channel, of course, is under that other cover. We'll get to that. And the great thing about this unit is by taking out 2 more screws, this driver unit lifts right out of the chassis. It's in a connector, which is just incredible how they engineered this mechanically. It couldn't get any easier than that. And the right-hand one that we'll get to in a little while is the same way. Now, this is great for restoration, but it's not so great for troubleshooting, because you can pull this right on out. I'm pulling it, and as I'm pulling it, I'm thinking, what's holding me up here? Because it was really stiff in that connector, and anytime anything doesn't give in something, you can see me almost picking the unit up by the driver assembly. So I'm kind of like, well, let me get over here, get a little bit different angle on it or something. But anytime you're pulling something and it's not coming loose, it makes you think, hey, what's going on? But as you can see, out it came. And isn't that wonderful if you're going to get in there and replace components? But as this is great for restoration, I would see this a little bit of a nightmare if you had to troubleshoot this board, because you'd have to troubleshoot it in the chassis. So you would have to probably troubleshoot it from underneath through that connector. Now you could use little mini grabbers and you could get a probe down in there, but it'd be awful tight and you'd just be turning the unit off continually trying to get to anything. And you certainly wouldn't get to the artwork side because it's so close against the heatsink. So that's usually the case though. If one thing is easy, then another thing's hard. But seeing I'm restoring it, I think this is wonderful because I'm holding it in my hand. And of course I'm going to do the right channel at the same time, so all I've got to do is repeat myself, is go ahead and take the cover off the right channel's driver cover, and then I've got a couple more screws to remove underneath. And of course you drop the screws in the unit and you got to fish those out. Finally I do that, get the cover off, and then the 2 screws for the driver. And then I'll take the driver out and I'll have both of them out on the table, and that's going to make it for a much easier restoration. About 5 minutes ago, I said I wasn't going to preach about you changing out your electrolytic capacitors. You can make that decision on your own. But you know what? I'm going to preach a little bit about it. Here's a classic scene you can see on any vintage audio form, and there's hundreds of them. That user A says their Marantz 2230 sounds amazing. It's like brand new. And then you've got the Pioneer SX950 user complaining that it's muddy, flat sounding. Why the disconnect between these two? They should sound very similar to each other. This infographic illustrates the biggest misconception in the hobby, the silent failure. Too many people assume that if a piece of vintage gear powers up, the lights glow, and the sound comes out of both speakers, it must be working great. But as shown in the comparison between the in-spec and out-of-spec diagrams, that's rarely the case. You don't need a blown main fuse, a loud hum, or a dead channel to have broken equipment. The reality is that critical components, especially electrolytic capacitors, chemically degrade over the decades. Doesn't matter how they were stored, doesn't matter if they were ever used, they go bad over time. And the result isn't usually catastrophic. It's a gradual loss of detail, reduced bandwidth, and increased distortion. Many enthusiasts are completely unaware they are listening to broken gear that just happens to still make noise. And it's not only old capacitors, it also is known troublemaker transistors, and there's a number of them in vintage audio equipment that can cause you all kinds of problems. And should be changed out on site if you have these in your vintage audio equipment. Just Google known troublemaker transistors in vintage audio equipment, and you'll find the list. Troublesome transistors aren't always as obvious as this. Let me show you another example. I'm going to show you how you can have defective transistors in your piece of equipment for years and not even know you've got a problem. This Pioneer SA-9900 integrated amplifier is a prime example of that. I thought showing you this on a graph was the best way to go. And this graph has a horizontal and it has a vertical category. The vertical is the DC volts and the horizontal is the timeline. And so this was captured in real time, and once this starts running, you're going to see this moving over a period of time. You're going to see the voltage going up and down. And this was measured at the speaker outputs of this SA-9900. I just powered up the 9900 and it hasn't come out of protection yet, so we're just kind of reading random garbage here at the speaker outputs. Now, right there, it powered up. And let me stop it here for a minute. And you can see that we had a spike up to just under 80 millivolts. And that's normal. That's not an abnormal thing to see, because you can see right immediately it started to fall back down. So there's nothing wrong with that there. So let's keep moving on here, and it's just going along and it's fallen down to about, I don't know, 13 millivolts, 15 millivolts of DC at the outputs. That's good. And now look though, look at that spike. Let's stop it again for a minute. That spike down of about negative 85 millivolts is not normal. And this is the kind of problem, I say, that people don't even know that they have. And these are the type of things that maybe started occurring 5 years ago, 10, 20 years ago. And eventually their piece of equipment doesn't work anymore, and now they think it's broke, where they didn't realize it had been broke for years. And you kind of think, well, why didn't the protection circuit kick in here? What's going on? The protection circuit in this unit doesn't kick on until about 750 millivolts, about 3/4 of a volt. So as far as the amp's concerned, he's perfectly happy. Now, of course, your music's not going to be sounding as clear and as crisp as it can, and you're suddenly going to be listening to it, and you're going to say, well, boy, this amp doesn't sound all that good to me. Or you've been listening to it like this for so long, you think it sounds great. So let's keep going here. And again, it pops back about normal. There we have another little spike up. And it's just going along here, going along here. And this is something that is random. I could do this again, and you're going to get a different result. You don't get the same result every time. And take a look again. Now look at the spikes. Holy smokes, now we got some more coming. And this time went to, 130, 133 millivolts on the positive side, and down around in minus 50 or so on the negative side. That affects the way this amp sounds. You may not know it though. You don't know it. And there's another spike, a big one down 152 and I don't know, up 100 or so. But those are the type of things that affect the sound quality. You don't know anything's wrong. The amp's just sitting there playing along, but it does affect the way it sounds. All these DC voltage glitches happened in a minute and a half, not an hour and a half, not a day and a half. So I think this is a good example to show you why just because your piece of equipment powers up, it doesn't necessarily mean that it's working properly. You can have a silent component failure, and that's normally the first step. And then you get to the step that I showed you where it may not be audible. It's kind of intermittent, but it's measurable. But eventually it's going to get to the point to where you're going to either audibly hear it or your piece of equipment's going to go into protection mode. So if you've got a piece of vintage audio equipment that doesn't sound like it used to, or it sounds poor compared to other pieces of equipment that you have, you've probably got a broken piece of equipment, because all of them should sound good when they're working properly. You can have a well-known diode issue that affects the Sansui BA5000's meters. This problem doesn't affect the BA5000's audio in any manner, but it affects the proper operation of the power meters. So to conclude this educated rant, don't be surprised if your 40, 50, or 60-year-old piece of vintage audio equipment has component issues. I do believe there's synergy between different receivers, amplifiers, speakers. Different combinations just sound better. And part of that has to do with the equipment, but part of it has to do with our ears. What we hear and how we process it is unique to each individual. But if you have one piece of equipment that you're never satisfied with, no matter what other components are hooked to it, I'd bet that piece of equipment is broke in some manner. And don't let anybody tell you the parts aren't available, because 99% of them are. It's time to get back to the 9600 and those driver assemblies. As I mentioned, this is so nice just to have it right in front of me. It makes it so easy to do this. As far as capacitor brands to use as replacements, pick a brand that's just a quality brand. I don't know that it matters a whole lot. Panasonic, Nishikon, or some other brand that you may prefer. As I mentioned earlier when I was doing the power supply, my desoldering gun is invaluable. I would not do this without this desoldering gun. And some of these capacitors were quite large. You can see the legs, they were pulled over at the factory to hold them into position when they flow soldered this. So it takes a little bit extra work to get them out sometimes. You just got to be careful, take your time, and just don't do any damage to the artwork. As I mentioned earlier when I was doing the power supply assembly, I just think it's better if you take out one component at a time, get the new one in there, and that way you don't make any mistakes, and then you try to put them back in just like they had them at the factory. I finished up both driver boards. I replaced those old electrolytic capacitors. Fortunately, in this amplifier, there were no other components that were known troublemakers that I mentioned earlier, like transistors or diodes that should be changed on site. So now it's time to mount these back into the chassis. The driver assemblies go right back into the chassis just as easy as they came out. And now with those new electrolytic capacitors, there's a good chance I won't ever have to get back into the driver assemblies ever again. But if I ever need to, you've seen how easy it is to get them out of the unit, and certainly it's easier to get them back in. I powered up the 9600, made sure everything was good, so it's time to move on. I'm going to change out that old thermal compound also that you have between the power transistor case and the heatsink, along with a mica insulator. I'm going to change that also. This will allow the power transistors to run cool, because with that new thermal compound, the case of the transistor will be able to transfer the heat to the heatsink much better. Old thermal compound gets old like old grease. It just gets all hardened up and it doesn't work as well. This amplifier has plastic covers over the power transistors, which is unusual, and looking at it, I couldn't really tell how it comes unclipped. And I'm dealing with a piece of plastic that's been in there 50 years around an area that gets hot. And any of you guys know about old plastic? As soon as you touch it, I was afraid it was going to disintegrate. It's pretty tight in there. You can't really see what you're doing. I've got a small light that I'm trying to look down through the heatsink with to just see if I can figure out how does this come out of here. I know it does come out because you'd never be able to get the power transistors out. There's no way I would ever find these covers anywhere. So I wanted to be careful and do my best not to break them. And finally, I figured out how it was attached and popped it out. And once I knew how the first one was attached, it made it easier for me to get the other ones out. With the plastic covers removed, now it was time to take the power transistors out. And it's just the standard 2 screws that you remove, and once those are removed, you're able to remove the transistor from the heatsink assembly. The transistors just pull out of a socket. They usually come out pretty easy. In this unit, it was a little bit more difficult because there was not a lot of room for my hand to get inside the heatsink. They were quite deep, so I had to use 2 fingers from 2 different hands to be able to squirm in there to be able to pull these things out of there. Now it's just a matter of cleaning up the old thermal compound on the transistor, on the heatsink, getting a new mica insulator in there, and then putting some new thermal compound on the insulator on both sides of that. And you just got to do that on each transistor in the unit, and then she'll be ready to go for the next 40 years. So I've done all the power transistors in the unit. Now the final step is to just put those plastic covers back on, and the 9600 will be all ready to go. Was this something I had to do? No, it wasn't. But those mica insulators are 3 cents a piece, a little bit of thermal compound, another penny or 2, and a little bit of time. It's well worth going in there and reseating these power transistors and making sure that this 9600 gets everything it needs to go another 50 years. It's time to get that gorgeous faceplate reinstalled. The only thing I'm doing to this faceplate is just wiping the dust off it. That's the only thing. I didn't try to touch anything up. I didn't try to repair it in any way. I think it looks great just the way it is. This 9600's all back together, as good as it's going to be. And now it's time to do some bench testing. But first, I need to set the idle current, and I need to check the DC offset again, do some bench testing, and then it'll be time for this amplifier to do what it was made to do 50 years ago, and that's to make some music. To adjust the idle current and the DC offset, you need the service manual. And unless you've got the rarest piece of equipment in the world, Google your piece of equipment and you'll be able to find a service manual to download. Practically all of them will have detailed instructions on how to measure the idle current and the DC offset. Along with the instructions on how to measure idle current and DC offset, the service manual will also give you detailed instructions on how to adjust both of those. I'm going to check the biasing of the amplifier first. So using the service manual, I hooked up 2 sets of leads to 2 separate meters. In this unit, they're very easy to get at. Some of them they're not so easy. This one's very easy. The service manual states that you should wait 5 minutes before checking the idle current. And this is not long enough. This is the one area where you'll find out if you work on these amplifiers that they need more than 5 minutes because they won't stabilize in 5 minutes. You need to give them a minimum 15 minutes, and even 30 minutes is better. I'm going to show you here in a minute how 5 minutes was not long enough. According to the service manual, my idle current should be 5 millivolts between the 2 test points that I'm looking at. After 5 minutes of running this unit, it was about 2.5 millivolts on each channel. About half the voltage of what there should be. I should have 5 millivolts and both channels are about 2.5 millivolts. But if you look at this, they're gradually going up. And after about 15 minutes, they were right around 5 millivolts. So if I would have done as the service manual said, adjust these after 5 minutes, my idle current would be much higher than what it should have been. So you've got to wait on these amplifiers at least 15 minutes, and 30 minutes is even better. It just takes longer than 5 minutes for most amplifiers to stabilize. There was no adjustment necessary for the idle current, so I moved on to DC offset. In the service manual, it says to check DC offset across the speaker terminals, and you really don't need a service manual to do that. Any of you guys have a receiver or an amplifier at home, you want to check your DC offset, just take a digital multimeter and measure between the positive and the negative terminal on whichever channel you're looking at, and you can see what your DC offset is. You saw earlier in the video when I first got this amp powered up, I checked the DC offset and it was only 2, 3, 4 millivolts on both channels, and it's the same now. So there's nothing to do there. So the DC offset looks good, the bias looks good, and now it's time for bench testing. Let's see how this 9600 power amplifier that was destined for the trash can does on the test bench. I've got my Sound Technology 3200 audio analyzer, a pair of 300 watt load resistors. I've got my signal generator set up, and everything's on and just about ready to go. It's just sitting there at about 0.4 of a watt. It's about time to crank this guy up and let's see what he can do. I've got the gain controls on the 9600 maxed out, and I control the input by the signal generator. I just keep increasing the signal straight in. Looks like this amplifier's channels are tracking pretty even. As I mentioned, the gain controls are full up and just about the same wattage is being output from both channels. While I'm doing this, I'm going to go ahead and see if the meter sensitivity buttons work okay. Right now, putting out 3.7 watts a channel, and it looks like it. Yeah, it looks like on the most sensitive, it just about maxes the meters out. So I cranked up the signal generator a little bit, and I got both channels running just about 11 watts per channel, 11.1 on the left channel, 10.9 on the right channel. And I went to get something to eat, so I left it just sitting there at about 11 watts continuous for about an hour or so, and I came back to check on it. I came back, put my hands on the heat sinks, just curious how warm's it getting. That wasn't warm at all. This amplifier is rated at 110 watts per channel into 8 ohms, and I'm using 8 ohm load resistors, so it's not pushing it too hard. But 10 watts, 10, 11 watts continuous, it's doing a little bit. Now I'm going to take a look at the harmonic distortion of the 2 channels. This Sound Technology ST3200A was state-of-the-art back in the 80s, and it still does a great job of testing. And with a push of a button, I can take a look at the harmonic distortion. Here I'm looking at the left channel, and it's 0.0368 at about 11 watts. And this amplifier is rated at 0.08. So it's well within its specifications, and with another push of the button, I can look at the right channel, and it's at 0.02. I doubt when this amplifier was unboxed 50 years ago in 1975 that its distortion was any lower than this. Over the next couple hours, I just increased the amplifier's output into the 20s, into the 30s. I'd let it sit for a little while. I'd go off and do something else. I'd come back. And no matter where I put it at, it was just operating flawlessly. I would feel the heat sink, see if it was getting warm, check the distortion on both channels, and it was outstanding, anywhere from 0.02 to 0.03, somewhere in there. It was just idling along with no issues. And you may be saying to yourself, well, it's a 110 watt per channel amplifier, should be idling along at 20 or 30 watts per channel. But keep in mind, this thing is pegged at 20 or 30 watts per channel. These aren't music peaks that are going up and down that you guys are familiar with. This is just hammered 20, 30 watts per channel continuous, which would put the peaks probably about at clipping for this amplifier. I again increased the output of the signal generator to bump up the amplifier's output a little bit into the low 60s, and I took a break. After coming back from break feeling quite refreshed, I continued on with the bench testing, and I went ahead and I felt the load resistors that have been running now for over an hour at about 62 watts per channel, and ouch, they're warm. They are actually warm. Like, I could touch them, but get your hand back off it. You don't want to lay your hand on there like you could have before. The amplifier's heat sinks felt warmer, but by no means did they feel hot to me. And do you remember that thermal paint that I talked about earlier in the video? It's still yellow-green. So it's not even warm whatsoever. It hasn't gotten to even 120 degrees Fahrenheit, which is way lower than this amplifier can operate 24/7 at. This thermal paint will only change color when the temperature reaches 120 degrees or higher, 50 degrees Celsius. It'll turn to kind of an orangey red color. With both channels driven at over 60 watts per channel for over an hour, this amplifier is still running its distortion rating half of what it's rated at, staying in that 0.03 range, and that's just outstanding for an amplifier that's 50 years old and that was in the shape this one was in. Even assuming a 4 times peak to average ratio for music, this amplifier running in the low 60 watt range per channel would be trying to produce 250 watts per channel with music. And there's no way it's going to be able to do that. It would clip way before then. Running this amplifier for an hour at 60 watts per channel is something this amplifier probably has never seen and will never see in normal usage. A home amplifier is normally not subjected to just one steady input signal like you would with normal music. The restoration work that I did to this amplifier gives me the confidence that I can run it on the test bench and put it through its paces. I'm not going to run it to its max. I'm not going to try to blow it up, but I'm running it harder than it'll ever be ran in my music system. And with that being said, I'm pretty confident that this amplifier will be running long after I'm gone. There are a number of modern pieces of test equipment that do a great job testing vintage audio equipment. My Sound Technology ST3200A is a wonderful piece of equipment, and I love it, but the modern test equipment can do so much more. I won't say it's more convenient, but it can do so much more than my old piece of equipment can. Pretty much every specification that's in your owner's manual for your vintage piece of equipment can be tested with the modern stuff. And I used it when I tested this amplifier. I used my old, as you saw, I used my old test equipment, but I also used the new test equipment. And I'm just going to run through some of the screens real quick to show you that, the modern test equipment's a great way to go if you're starting off from scratch. If you're trying to put a test bench together because the equipment itself is physically small, everything runs on your PC, it's all software driven, and most of it's not ridiculously expensive. You won't be able to probably figure out what's going on from this because I've got it running so fast. But I just wanted to give you guys who were thinking about getting a test bench together to fix your own equipment, that there is a lot of good test equipment out there that's not ridiculously expensive that can help you fix vintage audio equipment. With the restoration and bench testing done, now it's time to listen to the amplifier. Will it ever look like it did in 1975? No. But I truly believe this amplifier is now operating like it was 1975, and I just brought it home, and I'm a teenager, and I'm ready to hook it up. I've got it hooked up to my preamp. I've got it hooked up to my speakers, and my parents have left the house. If you enjoyed the video, I hope you leave me a like. If you're not subscribed, I hope you leave subscribed. And if you are subscribed, as always, you know how much I appreciate you guys who've hung in there with me. Y'all have a good day.